Good morning, guys. It's Mrs. Blankenbeckler. I'm going to give you a short video, or actually two short videos, on 808. I feel like some of you guys really benefited from the less class connect time and more work time. So I'm going to give you kind of some options. So this is my first day to kind of do the options within my class connect of either staying in class or watching the video. So let's start with this one first. In lesson 808, we're looking at all three forms of the quadratic formulas. A quadratic can be in three forms. The first one is standard form, where we have y equals ax squared plus bx plus c. That is our standard form of a quadratic equation. The second one is, and it's the same quadratic, just changed around. It's going to be ax minus h quantity squared plus k. And this is in the hk, or the vertex form. And if a quadratic is in this form, we can actually pull out hk to get the vertex. And the final form is y equals, or I could say f of x, let's see, is in root form. And that's when it's in factored. X minus the first root times x minus the second root. And that's in root form. So you can get the x-intercepts. So these two r's are our x-intercepts. Now we have a couple ways to find the axis of symmetry and the vertex from these. And we've already learned those. We've got that negative b over 2a to get the vertex out. And then we can add the two roots together and divide by 2 to find the axis of symmetry for those. What we're going to do today is we're going to take the second two forms. So we're going to take the vertex form and the root form. And we're going to learn how to write the equation if we're not given the equation. If we're given either x-intercepts of the vertex and 1 point. So the first one I'm going to do is actually from the homework. It's an even problem. And I can't remember which even problem was in there. And this one has the x-intercepts and 1 point. Well, if I have x-intercepts, that is a root, isn't it? So I'm going to use this formula to create my equation, or solve for a. So I'm going to take y equals x minus root 1 times x minus root 2. And I'm going to take and plug in all my information. This point is a point on the quadratic, and that's an x, and that's a y value. These are my two roots, so they're going to go in for the two roots. So I'm going to plug in negative 15 for y. I'm going to plug in nothing for a, because a is what I'm solving for. I don't know a. X is 3, so 3 minus my first root is minus a negative 2 times x again, right? I have a second x, so I'm going to put 3 in there a second time minus for my other root. Okay, now notice I have everything plugged in for x root 1, x root 2, and y. I only have an a left, or one variable left. Now I can solve for that. So I'll bring down my negative 15. I'm going to simplify this to a times, double negative is a positive, 5 times 3 minus 4 is negative 1. So I have negative 15 equals, and if I simplify this, I get negative 5a. So a is positive 3. Okay, now that I have a is positive 3, all I have to do is go back and plug it in, okay? So I'm going to plug in y equals positive 3 for my a. Now, what else do I need to plug in? My x and y change based on where I am on my quadratic. So I leave my y and my x as my variables. I'm only going to plug in my roots. So I'm going to put a minus a negative 2 or plus 2. And the second one is x minus 4. And voila. There is my answer. Okay, so my final answer is y equals, or you could have f of x is equal to 3, which was the a we just solved for, minus the first root minus the second root. Okay, and that's how you find the quadratic equation given 2 roots and a point. And there's part 1. Okay, I'm going to do a second video for you that's going to focus on the vertex formula. Given a vertex and a point, how do you find the equation? And it's the same kind of process. But here's part 1. I did the 2 roots with a point first, and then I'll do the second one in just a second. So good luck.